So today's video is to show the effects that LED dimmers or a switching device can have towards a high gain amplifier if both of them are connected to the same power supply. So as we see, one cable runs out, goes to the power supply, both of them are powered, as we can see, with 12 volts. Then how does the configuration work? So this amplifier is a high gain amplifier. It's a non-inverting amplifier, op-amp of course, and here I'm going to show a small drawing of what we have configured in this situation. So as you can see, we have a single supply non-inverting amplifier powered with 12 volts, and the input in our case is this coming from my audio card. Because I'm so poor, I cannot allow myself a function generator, and I'm using an online function generator. Then the output of this guy is connected to my oscilloscope. Haha, I cannot afford myself a function generator, but I can buy an oscilloscope. And this is currently the output we have. So we have a very small signal and fed into the amplifier, and we have an amplification of approximately 100 or a gain of 100, and in this case the power fed to both of them is through the same lead. So as you can see, this is just a jumper to short, and I'm gonna show the effects that this has when both devices are connected to the same power supply. You probably have heard about the myth that says, well, myth, it's actually a fact that says, don't connect your audio amplifiers to the lights when you're making concerts or at home or whatever. Well, I'm going to prove with a very nice simple example that this actually happens, and it's a very serious problem that you need to take care of. So let's go into the demonstration. So now my dimmer is turned off, so you can see I can crank it up, and I turn on the mini DIY LED strip that I made, and now we're gonna look at the output. So as we can see, now the LED strip is fully turned off. I'm feeding a very small sine wave into the input, and it's a 1 kHz sine wave, as you can see at the bottom right of my oscilloscope. And now, just to prove that I'm really feeding a very small signal into the input, I'm gonna feed it to the input. So you can see the input is not visible at all, and I have connected it to my input, as you can see. So I'm gonna unplug this thing. I'm gonna plug it back into this input. It's a bit difficult to plug something to a very small hole on a breadboard when you're trying to record and show stuff at the same time. Oh! Very nice, I messed up something. Now I have a DC output. Oh, okay. I think I'm gonna pause the video for a second. So yeah, actually what I am doing here is actually plug it to the wrong hole. So it has to go here. This is my output. So yeah, there we go. Mistakes that you do when you want to go quick. So let's go into the thing. Now what I'm gonna do is I'm just gonna crank up the dimmer. As you can see, turns on, and we can see this horrible distortion or noise present in the signal that occurs. Let me just change a bit the triggering level. Hopefully I can stabilize the wave, kind of. And now, as you can see, I'm changing the brightness, and as you can see, the noise goes to worse, and then it goes to almost no noise, although there is still noise because the dimmer doesn't go to fully turned on. It never goes to a PWM 100% in this case. This is how I decided to design it due to all the reasons. And when I go to, let's say, around, this would be 50%, the noise is in the worst situation, as we can see. So now I'm gonna show how to fix this problem. So just give me a second, I'm gonna pause the video and change a bit the circuit around here. I'm gonna show what am I doing to fix the situation. So here we're back here again, and now what I have done to the circuit, as you can see, this bulky component, this is a choke, and the choke is placed in such a configuration that I'm gonna show in my incredible drawing skills here again. So the choke is configured in the following situation. Just give me a second, place it in, there we go, that's better. Get a magical screwdriver. So here we have the input, the 12 volts, and the ground that we also provide, or 0 volt reference that we provide from the power supply. We have our choke, which is basically two inductors connected, well, not connected together, they're isolated, but they're magnetically connected through a core and etc, etc. You can read a bit more online how does the thing go, but just to say they're magnetically connected, so it would be like more like a transformer in such a way. So, but the ratio of windings in between this side and this side is equal. And the output is also 12 volts, but they call it clean output. And then also the ground is the clean output. So just to prove you that this is only the thing they have connected, as you can see, I don't have in this section will be the power section, the 12 volts. As you can see, I don't have any decoupling capacitors. I'm not doing any black magic, and I'm going to show later the proof that is actually not just this thing acting as this situation here acting as a low pass filter or some stuff like this to filter out the high frequency noise generated from the dimmer, but it's actually canceling that high frequency noise because this one creates like a differential signal, etc, etc, etc. It's too long to explain. I just want to show in a more practical way how does this thing work. So as we can see, we have this configuration. Now I'm gonna crank up the dimmer, and just to prove, cranking up the dimmer, no noise whatsoever. We have a clean output. And just to prove, I'm gonna zoom back, move back a bit, so you can see that I'm actually cranking up the dimmer. I'm not doing any black magic. So yeah, here I go, crank up the dimmer, no noise whatsoever. And that's because when the signal, the noise is not only present, the switching noise is not only present in the 12 volt line, but is also present on the ground. So we will have the noise present here and here because of the switching. Just give me a second. There we go, that's better. Present here and here the noise. So when the switching noise comes that we saw here, comes from this side and also comes from this side, because this one and this one are equal in this situation, the signal will cancel each other, so we'll give a quite, or what we can call a clean output. So it will give a clean DC output. Of course, the problem here is that you cannot just put this thing anywhere. If this choke, in this case, this system consumes barely any power, some like 10 milliamps it could consume. But in this case, this could be used as a preamplifier, so no problem. You don't power a big load like a power amplifier could power an 8-ohm speaker load. But if the load is too big, you cannot just use this choke. This choke would be huge to be able to handle the power going through. This is a mains voltage choke provided from the guys from Wurt Electronic. And yeah, it's used for mains voltage, in which the side that in the mains voltage side you will have, in the case of Euro, 230 volts, but you will have lower currents. And in this case, it's just 12 volts DC and a couple of milliamps flowing towards the amplifier. Although, just to prove that even if I put a low pass filter, it just doesn't work because the noise is also present in the ground. So I'm going to pause the video, change the circuit a bit, and show the situation. So back now, change the circuit a bit, let's find the magic screwdriver. And what we have here is, what is this? Is a second. Oh yeah, okay. It's 1 millihenry inductor from Cocraft, as you can see. Nice advertisement there. And this guy over here is 2200 microfarad Philips capacitor, and this is a quality capacitor. And of course, here in the Netherlands we have plenty of these guys because thanks to Philips. Oh, just a second to find another replica of this guy, or same guy. So this is, as you can see, Philips. I'm not kidding, is a quality capacitor what we have in here. So going back to the thing, so to prove that actually this, as I said, this noise is present also in the ground, I will zoom back and I will crank up the dimmer, and I will show in the oscilloscope that this actually continues the noise. So as you can see, I'm cranking up the dimmer and the noise is still there. I crank it down, disappears. And I will prove, here as you can see, the ground is connected to just the jump board, and I just have what we can call a low pass filter happening between this inductor and this decoupling capacitor, and actually this way I prove that actually the noise is present in both ground and power lead, and to be able to cancel it you need to use a choke which creates this the equal signals, and by equal signals, so let me try to make some black magic by drawing and recording at the same time. This is going to be hard. Here we're going to have the 12 volts, and here we're going to have the ground, so 12 volts, 0 volts. So we're going to have the switching noise, something like this, I guess we can call it, and this is something like this also, let's call it. So here, by having this equal signals and this configuration, these guys will get cancelled, and this will be just a straight line. Of course, as I said, the biggest disadvantage, your main disadvantage, if you're consuming too much power, this guy or this configuration, well, not this configuration, the choke configuration doesn't work because it's just too much power to handle. But the best way to do this is also in audio application, concert sound, studio sound. Just plug lights and audio to different inputs, different power supplies, and have them as further away as possible so they don't interfere with each other. You don't have switching noise, you don't have ground loops. Well, ground loops is a different story, probably for another video. And also you don't have the switching noise from switching power supplies, like for example LED lights. That's why I used LED lights. Is something very popular nowadays, and it's widely available, so you probably have LED lights in your studio or office or wherever you're gonna do it. So thank you very much for watching this video. Appreciate your attention. See you next time.